Hey guys, what's up? So the other day, me and my friend Megan were in Austin. We were going to Barton Springs Creek, but first needed to go fill up her Toyota Corolla. So we went to the gas station, and Megan starts to go for the most expensive gas. And I was like, what are you doing? She said that her car ran better on the good stuff. I don't think so. I think Megan might need a lesson in chemistry. Megan didn't quite understand what all those numbers meant at the fuel pump. You've seen them, but have you ever wondered what they really meant? Those numbers represent a rating system that tells you how well the fuel burns in your car. But bigger isn't always better. You'll see why. You should know that octane and heptane are the main components of gasoline. Octane and heptane are 8 and 7 carbon-containing molecules. They also have a lot of hydrogen. This is why they're called hydrocarbons. You're looking at an oil rig in the Gulf of Mexico. Gasoline and other hydrocarbons come from oil. They are hugely important to our society. They're used to fuel cars and airplanes and electricity plants. They're also used to make medicines, cosmetics, and plastics. When you brushed your teeth this morning, you used a product from oil, toothpaste. Look at your shoes. They're a product made from oil. Next time you're playing basketball with your friends, think about the ball you're dribbling. You guessed it, the rubber to make that ball came from oil. Anyway, when you see the number 87 at the pump, it means that the gasoline burns as well as a mixture of 87% octane and 13% heptane would. All other numbers are compared to this standard mix. The larger the number, the more compression the fuel can handle, and the greater amount of work it can do when it burns. So percentages are important at the fuel pump, but also in the chemistry classroom as well. You've heard of percent composition, right? Chemists use percent composition to find the best possible source of an element. Let's look at that definition. Percent composition is the percentage, by mass, of an element in a compound. You'll need to use this formula to figure out percent composition. It's kind of like when you're trying to figure out what you got on a test. Percent composition equals the mass of an element divided by the formula mass times 100. Here's octane. It contains 8 carbon atoms and 18 hydrogen atoms. Let's say you want to know what percentage, by mass, carbon contributes to the compound. First, you've got to look at the periodic table and find the formula mass for octane. Each of the 8 carbon atoms have a mass of 12.01, and each of the 18 hydrogen atoms have a mass of 1.01. Multiply the number of atoms present by each element's atomic weight, and you get the total formula's mass of 114.26 grams per mole. Now, plug that into the percent composition formula. Okay, so the problem asks us to determine what percentage, by mass, carbon contributes to the compound. That means we need to put the mass of 8 carbon atoms in the numerator. There are 8 carbon atoms. Multiply that by carbon's atomic mass, which was 12.01. Now plug that into the numerator and solve. Divide by the formula mass and multiply by 100 to convert the decimal to a percentage. Octane is 84% carbon. That means that the rest of the mass is due to hydrogen. That should be 16% hydrogen, but we'll do the math just to be sure. Now we will use this formula. We already know the formula mass of C8H18, so plug that into the formula. To find the mass of the 18 hydrogen atoms, multiply 18 by hydrogen's atomic mass of 1.01. Now plug that into the percent composition formula. Divide by the formula mass and multiply by 100 to convert the decimal to a percentage. Cool, so octane is a pretty carbon-rich fuel source. Okay, now back to the pump. The 87, 89, and 93 numbers at the pump indicate how much octane is in the gasoline and how well the fuel burns. My friend Megan drives a Corolla, and it's 4-cylinder, and her engine can't tell the difference between 87, 89, and 93. You can't make an engine that normally runs on low-octane fuel run better by using high-octane fuel. But you can make an engine that's designed for high-octane fuel run less powerfully by using low-octane gas. If Megan drove a nice sports car, it would make total sense to put expensive gas in it. But her Toyota will always put along no matter what type of gas she puts into it. So we finally get to the pool after I schooled Megan on octane, and we get to swimming. After a while, we get hungry and Megan pulls out some snacks. Once again, I'm shocked. I ask her, "What are you eating?" And she's like, "Chill out, they're just crackers." But did you look at the label? I tell her she can't eat them. Here's why. The serving size is 5 crackers, or 15 grams. The total fat is 3.5 grams. Using the percent composition formula, you'll find that crackers are 23% fat. Ew. Whoa, when you look at it like that, I think I'll stick to an apple. Nutrition labels can be confusing, but understanding percentages can make it a little easier. I'm glad I was there to help Megan with her math and chemistry. Believe me, the stuff you learn in class can be incredibly useful. That's it for now. See you later.